Okay, let's look at section 9.1. This section talks about functions and the equality between functions. All right, let's look at the definition. A function we can call it the function f from a to b. So this is a notation, right? Is simply a relation which from a to b, which means that f is going to be simply a subset of a Cartesian product of the Cartesian product A cross B. Right? So a function is a kind of relation such that, so put such that, right? It has to satisfy this. For each element A in the set A, there exists exactly one corresponding element, say B, in set B, such that A is related to B by this function or relation f, right? There's a different notation. Instead of writing A is related to B by this relation f, we can also write it as, so this is exactly the same thing as, we can also write it as f of A is equal to B, right? Or you can say B is the image of A under the function f. Right, so that's just another way to say it. All right, as a relation, we can talk about domain. So domain of this function f is actually the entire set A. Right. If you're looking for codomain of this function f is the entire set B. But if you're looking for range of this function f, that will be a collection of B, element B in the set B, such that there exists some A in A, such that f of A is equal to B. All right, but the short notation would be you can write it as f of set A. So that will give you the range of f, right? And if you want to talk about the equality between two functions, all you really have to do is, let's say you have two functions, f and g, functions from A to B, right? We say two functions are equal to each other, so f equal g, if for all A in A, right, f of A, f of A is equal to g of A. Right. So this is a definition of equality between two functions. And there's some remarks. All right, since for all element in A, there exists exactly one element B. So if you look at the cardinality of the function f, okay, is always equal to, because f would have the same number of ordered pair as the cardinality of A. So it's going to be, so cardinality of f is exactly equal to cardinality of its domain, right? Then if you look at the inverse image, so since this is a relation, we can talk about inverse. So inverse image of say entire codomain B would be always the domain A, right? Maybe we should draw a picture. Let's say if you have say function f, so A would have some elements. Let's say, let's do a simple one, 1, 2, 3, and B would have a few elements, say A, B, C, right? So 1 could be mapped to say B, and 2 could be mapped to B, and maybe 3 could be mapped to A, right? So this is a perfectly good function f, right? So you can see that for every single element in A, there exists exactly one corresponding element. And it's okay to have two different element in A is mapped to the same element, right? But each one has one corresponding element. So this is the condition to become a function, all right? And you can see that the entire set A is going to be a domain of this function, and the codomain would be the entire set B. But if you're looking for the range of this function, it would be the set with elements in B that has arrows coming in. So you can see that the set here, just A and B. So this would be the range of this function f. All right, that's it. I hope that this was clear.